Hello, guys. Now it is time we talk about the gravitational potential energy. Now, what is gravitational potential energy? Gravitational potential energy is the work done by the gravitational force in taking a mass from infinity to any point in the gravitational field. Okay? Sometimes they define it as the work done by the gravitational field in taking a unit mass, that is a mass of 1 kg, from infinity to any point in the gravitational field. Now, what we do today is that we derive the formula for gravitational potential energy based on the definition of gravitational potential energy. Now, let us imagine a planetary body, say Earth, planet Earth. Now, see planet Earth here. This is planet Earth. So, this is the center of the Earth. Now, this is the orbit with radius at infinity. Okay, so that is the radius from the center of the Earth to this orbit. The radius r is equal to what? Infinity. So let there be a point in the Earth's gravitational field. Now this is the point, the point in the Earth's gravitational field. Now this point is P. Okay, so now, from the definition of a gravitational potential energy, we say that it is the work done by the gravitational field in taking a mass here from infinity to this point P. Do you understand? Good. Now, let X be the length from the center of the Earth to here. That is, this is X. Okay? So this is X. Good. Now, you see this X now, this X is representing any distance from the center of the Earth to anywhere. Do you understand? That is at infinity. Do you understand? So, now, see what will happen now. See, remember, this point is infinity. This is point infinity. This is point P. Do you understand? That is, at this point, X is equals to what? Infinity. At this point, X is equals to what? R. You know, the radius from here to here is what? R. Okay? The radius is what? Is R. Now, you know, we define it as what? The work done by the gravitational force. So, work done is equal to what? Force times distance. That is F cos theta times what? Distance, X. Do you understand? This is the equation of what? The work done. And when gravitational force is doing that work, the direction of the gravitational force and the direction of the displacement, they are the same. That is, in this case, theta is equal to what? 0. That is, this is the direction of the gravitational force, downwards. This is also the direction of what? The distance. Do you see it now? Correct. So the angle between them is what? 0. That is why I say that theta is equal to 0. So from here, we have that the work done is equal to what? That is F times cos 0 times X. So therefore, the work done is equal to what? Force times what? Distance. Do you understand? So from here now, we now add up all the work done from this point at infinity. From this point at infinity to this point. That is from X equals to infinity to X equals to R. This is the infinity point. This is point R. Okay. Now, we now consider the work done from infinity to here. That is, we sum them up. That is, in this case, there is a change in what? In X. You know, this is X. Do you understand? The distance X. So from here to here, we call from here to here a change in X. That is the X. Do you understand? Good. So now, summing up all these little change, this change in X, like all of them, summing them up, we need the integral. Okay, the definite integral. So we now say that the gravitational potential energy V is equals to the definite integral from infinity to a point, to the point R. Okay, the definite integral of the work done. Okay, so which is force times what? Distance. Okay, so from here we solve this integral. We solve this integral from here. So we now say that we now have that. Remember, This distance is that the x, okay? So s is equals to the x, and force is the gravitational force, okay? Which is what? Equals to gmm over what? X squared. You know, the distance is x. You know that distance I drew from the center to infinity. Do you understand? And so that's what x is representing. So we now say that v is equals to what? The integral of infinity. The limits are infinity to r. That is gmm over x squared times what? The x. So now we now do v is equal to what? Equal to gmm integral infinity to r 1 over x squared dx. So we evaluate this integral. You know that the integral of that is x raised to power n dx is equal to what? 1 over n plus 1 x raised to power n plus 1 plus c. This is the integral. So now we now have this integral now becomes, that is integral of 1 over x squared is equal to the integral of x raised to power minus 2 dx. So from this formula we have 1 over minus 2 plus 1 x raised to power minus 2 plus 1. Do you understand? So we now have that is 1 over minus 1 x raised to power minus 1. Okay? So x raised to power minus 1. Now, which will give us minus 1 over x, you know, after everything, it will give us minus 1 over x. So we have evaluated this integral. So now, we now say that v is equals to gmm times 1 over x, minus 1 over x, you put the limit of integration, r and what? Infinity. So which is what? That is v equals to gmm, then this is gmm bracket minus 1 over r minus bracket minus 1 over infinity. Okay? Bracket close. Minus 1 over infinity, bracket close. So remember that minus 1 over infinity is equals to what? 0. This is equal to 0. Okay? So everything here will give you 0. Remaining minus 1 over r. So finally, we obtain that v is equal to what? V is equal to, that is gmm, then times minus 1 over r. So the formula becomes minus gmm over r. So this is the formula for the what? Gravitational potential energy. So this is it. So in my next video, I will tell you another approach to this. Okay? So for now, just take this one for now. See you guys in my next video. I hope you understood everything. If you don't understand it, tell me in the comment section so that we know how we do. I will explain it further there or help you to understand it there.